Sorry about that, everyone.
Is something gaming, but the general goal is to give you the basic tools necessary to be able to build immersive, interactive VR experiences. And the use case that we're looking at today is something like architectural visualization for internal settings. So we're actually going to look at converting an existing very high definition architectural visualization scene for the inside, the interior of a room, and we're going to convert that from being a very static real-time experience to something that is VR, and we'll look at all the tools needed for that. So for our agenda, we will talk very briefly about the history and a couple of use cases for VR outside of gaming.
Can I just check that everyone can see the video? Can you put in chat if you can't see the video? It is working fine? Okay. I just wanted to double check. Thank you.
Then we'll have a live demo, and then very briefly I will talk about PaceLab Weaver, which is a verified solutions partner for Unity. That is a tool for building VR-based training experiences. So if that is a specific aspect of VR for industry that you're interested in, there can be a lot of work involved to build VR training. It's quite a lot of work, not just in the actual experience, but also in sort of content management and user control and back-end systems for assigning and storing results. And PaceLab Weaver sort of answers a lot of that. So we'll take a very quick look at that at the end. So when I say history, I really just wanted an opportunity to talk about this man. So my colleague, Paul Kupis, introduced me to this man, not to the man himself, but to the story of the man. This is Morten Hellig. He was a true Renaissance man. In 1957, when most people still had a black and white TV, he invented not just stereoscopic display, but a full 4D experiences: sound, wind, vibration, even smell. Of course, it completely failed as a commercial product at the time. The world was nowhere near ready for it, but we're still catching up to him. His Sensorama machine sat unloved next to a pool under a tarp for generations. Look him up. He's really fascinating. His 1962 patent application can be found online and includes a great amount of detail on his ideas for the potential use cases for this. Let me quote him quickly here. There are increasing demands today for ways and means to teach and train individuals without actually subjecting the individual to possible hazards of particular situations. So let that nugget sink in a little bit. He says his invention would give a better idea of a situation without putting anyone in danger. He's talking about VR training in 1962. Anyway, cool guy. Definitely read up on him. Super interesting man. This projection from Statista.com shows worldwide investment in VR and AR technology for training and industrial maintenance is likely to reach $4.1 billion US by 2024, which is quite incredible. Companies are already embracing this. This is a Walmart advanced retail training, whatever that is. I'm just going to play this very quickly. It doesn't go for very long.
When I first heard that Walmart would be using VR training in the academies, I thought it was awesome. It was really impressive just at the level of investment that they were willing to put in the actual training piece of our associates.
You see everything that the customer sees. It makes you just actually feel like you're in the situation at that time, so you get that personal one-on-one training.
We would teach them how to cull and what to look for on the wet wall and how to crisp and produce. We used it on the front end. How do we capture shrink? How do we serve customers?
For the Black Friday event, for example, we know what to look at, what other stores are seeing, how they're interacting with the customers.
As technology advances, we advance the way we train our people. And that investment, I think you'll always see a return on.
This story I found for Natuzzi. It was a little bit old. This was August 2019. So I don't know how much COVID affected their plans, but they had at the time what they called a new era of advanced white glove customer service. So to begin with, it was using HoloLens and allowing customers to interact with the environment, move product, change patterns, etc. They plan to roll out more augmented stores, and their initial plan was to have it in all of their physical stores worldwide by the end of last year, 2020. Like I said, though, I'm not sure how they did. The expectation was that it would reduce costs and space requirements, allowing them to expand their store coverage. They also planned to have full VR experiences that brought in the customer's own home using photographs, measurements, and potentially CAD files if the customers had them. And it would have a focus on architectural elements such as walls and floors and doors and windows, and being able to modify those and customize those and look at different options for those. So super interesting use case there. I would love to find out more information about how they went with that and whether or not the pandemic slowed that process down. So this is a virtual reality experience that gave people more access than the official show attendees. So this was a fashion show, and what they did was create a sort of live stream VR experience that had multiple media streams coming through, including the front row and backstage positions. There was positional audio, there was live tweet feeds coming through, there was a time lapse of the set being built with 360 still photos that you could jump into. And sure, maybe none of you are in the fashion industry, but this tech can be applied in multiple areas, right? What if your stakeholders are virtually on site while someone is physically there with a 360 video cam, right? You can be pulling multiple streams of information, having live discussions, and there's only one person physically needed on site. And even then, that's only if you want sort of live video audio, right? You could potentially capture that asynchronously and still have the whole thing virtual. So this was pretty cool.
The brief was to open up Topshop's fashion show at London Fashion Week, which was taking place in the Turbine Hall in Tate Modern, to a much wider audience. And the idea we came back with was to use virtual reality to let people attend the show using a thing called Telepresence. So we actually transmitted the show from a front row seat in the Turbine Hall to 5 Oculus Rift virtual reality headsets, which were in the front window of Topshop's flagship store in Oxford Street. And then for 3 days afterwards, we switched to an on-demand system where people could watch the show as live and have a very similar experience. So the idea was to bring together as many possible strands of content into one Topshop space. And Stavi's going to demonstrate here what they can see. So just put the Oculus Rift headset on. And we also had stereo sound, which was positional as well. So as you move your head around, you actually get a sense of sound in the 3D space. So the front row here, you can see we have this 180-degree view of the front row. You can see people sitting next to you to the left and right. You can see celebs across, and obviously you can see the girls walking along the catwalk. And if we look behind, we've got this secondary screen. So at the moment, this is showing a time lapse of the set build. But by simply looking at the switch below, we can actually select the backstage live view as well. Another full HD feed that we had coming through. If you look up, right up into the gap in the top of the roof, you actually float up into the second space. And this is one of the 360 still images that was taken, 360 selfie there. And this is a slideshow that moves through images, and these are coming in live during the event. And if Stavi looks back down to where she came from in the hole in the floor, she'll float back down into the original room. Now this room was designed not only to reflect the aesthetics of the Tate Modern, but also to reflect the themes of the autumn-winter.
So you get the idea. Very, very cool use of the technology, and I think a real eye-opener to the idea that VR doesn't have to be this one-to-one copy of some reality, right? You can do things with it that you could not do physically. You can fly up into the sky and look at other things. You can look behind you and see time lapses of things that have already happened. All right, there's really just the limits of your own imagination to what you can do and how that can become useful. right? But there's many more as well. You know, there's healthcare, there's education, definitely. Virtual tours for real estate, I mean, that definitely already happened, at least for house viewings, but I know over the course of the pandemic, there were lots of tourism companies that were looking at selling virtual tours and trying to figure out a way to be able to do that. Marketing and gamification. McDonald's did a promotion for a while there where their Happy Meal boxes could actually be converted into like a Google Cardboard. So they came with little lenses and they were designed to push out on the perforated areas and fold in a certain way and slide the lenses in and then pop a phone in, and you had a Google Cardboard made out of your Happy Meal box. Of course, product review, which is quite common in the AEC sectors, but also in the manufacturing areas as well, like cars. And product review is a pretty broad term that could go anywhere from the very early concept stages of designing something to actually selling a product to a consumer. So the sky is the limit, kind of. So what I want to do today is show you how easily you can add VR to a Unity project, right? And add basic interactivity so that you can build your own prototype experiences. Now, the idea is to be able to build this stuff really quickly, get visualizations happening very quickly, get some feedback happening very quickly, so that you can design out and figure out what is something that is unique and powerful to the way that you do business that can improve it, that can make it more productive or more successful. All right, so thanks to Unity, a lot of visualization, 3D real-time visualization is already moving into the real-time space, right? Benefits are already being reaped. Companies are already creating real-time 3D visualizations of everything from products to spaces to buildings, to potential buildings, to design aspects of interiors. And maybe you're already working in that space now. Maybe you've got a team at your company that's creating visualizations in Unity, or they're creating visualizations in something else, and you want to have a crack at VRifying that, right? And that's what today is all about. So it's live demo time. Yeah, this never goes wrong. So I'm going to switch over to Unity now.
Okay, now you can see here that we are in a ready-made scene, and you might be thinking to yourself, but Adam, this is a pre-made scene, it's already set up to go. It kind of is. What this is, for anyone that didn't see it, this is Yifei's fantastic lighting webinar from maybe a couple of months ago. It was all about HDRP lighting, and it uses the high definition render pipeline. This particular one is set up with mixed lighting, meaning that some, in fact, most of the lights in this scene have been baked, and some of them are real-time lights. You definitely need to think about performance when you're talking about VR, and having real-time lights or excessive number of real-time lights is definitely going to present an issue. So you want to be smart about baking certain lights that you know are going to change, and baking certain objects into that. So some of these objects have been baked in. I think the laptops on the table, for instance, if we look at the laptops down on the table, in fact, let me go in here. All right, so if we have a look at these laptops, you can see they're casting shadows onto the table. Those shadows have been baked in because they're being driven by one of the larger lights here that's coming in through the window. And so if we make the laptop able to be picked up in VR and moved around, we're going to break the immersion because the shadow's not going to go as we've baked onto the table. So you need to think about that when you're designing your VR scene. You need to think about what's going to be interactive and what isn't, and anything that isn't going to be interactive or movable, then you want to make that static and baked in to improve your performance or get as much out of your performance as you can. You don't want a low or inconsistent frame rate in VR because that's going to cause some motion sickness. And in fact, an interesting fact, there was a designer, a VR designer from Disney, and Disney, their physical theme parks have been using VR in rides and attractions since well before the sort of modern popularization of VR. And they discovered a long time ago through experimentation that a low frame rate can be off-putting, but most of the motion sickness comes from a variable frame rate or an inconsistent frame rate. So if the frame rate is subpar, and most of the literature out there says you need somewhere around 90 FPS to avoid motion sickness in a majority of the users. But Disney have found that you can actually get lower than that so long as it's consistent. It's when the frame rate is fluctuating quite a lot between frame rates that the motion sickness really starts to kick in. So even if you're getting 90 and it's dropping back down to 75 periodically, or in certain areas, that's going to cause a lot of more motion sickness than if you were just a consistent 75. At least that's what I read. So why have I used this? And can I show you how to do this in a clean, empty Unity project? I totally could use a clean project, but there's a couple of reasons not to. First, the steps are exactly the same. Right, this project has nothing VR specific set up about it. So from the setup side of things, to all intents and purposes, it's exactly the same as if this was a completely empty project. The reason I'm using it is so that you can see something that looks like a valid use case. It's not just placeholder cubes that are out of context. It also is has some performance overhead, right? It's a practical, real example that has a lot of post effects already added in there. It's got high definition lighting. It's got a heap of objects. It's got some baked and mixed lighting, right? So it's not an empty scene that I've dropped some cubes in, hit play, show you how to do it, and it works perfectly, and then you take it away and try and apply it to your own visualizations, and you're seeing there's performance issues because it's much more complex, right? I wanted to start with a complex scene. So I haven't touched anything in this project yet as we're looking at it just now. This is just the project that Yifei sent to me that he used for the lighting. There, in fact, isn't any camera controls built into this. When you hit play, everything runs in real time, but there's nothing you can do about it. I think there's actually a TV behind the camera here that plays a video, I think automatically when you start playing. We'll modify that later. We'll build some controls to be able to interact with that in VR, but the scene as it stands is just a very static visualization. I mean, it all runs in real time, but there's no interactivity. And this might be the type of scene that you already have, or that you've seen someone inside your company doing, or that you are interested in doing, or have seen or heard an interest from your bosses in seeing. But, you know, they look nice, but then you're not really utilizing any of the real advantages of real-time 3D. Like this is almost just a render because there's no interactivity. It just happens to be running in real time. So our aim today is to make this into something that's interactive. So let's start with setting up VR. So the number one thing you want to do when you're talking about using the high definition render pipeline in Unity, and you want to use VR, and that is to turn off the motion blur. Right, so if we go into the HDRP default settings, this is in the project settings, which you can find. I have mine set up so that panel is always sitting next to the inspector by default. This is my usual personal layout that I have saved. But by default, it won't be there when you not use any of the normal layouts, and you just find it under Edit, Project Settings. And because this is a HDRP project, I have this default settings here, and you'll see that motion blur is ticked. Right, so it's on by default. We definitely don't want motion blur on by default. The whole point of VR is that you're turning your head and getting the motion blur naturally. So don't add it in. It adds a lot of performance overhead, and it will really add to the motion sickness. Now, the next thing we're going to do is add in the XR packages, and then we'll come back to a couple of the other settings. Right? So we go to our package manager, Windows, package manager, and then we're just going to look up the XR plugin manager. That's the system that handles all of the different XR platforms. So if we go to the Unity registry and we type XR, and we'll see the XR plugin management system, and we're just going to install that. Now, the other thing we're going to take advantage of is the XR Interaction Toolkit, which is a package that is still in review at the moment. It's a preview package, so it hasn't been officially verified, but it's got a whole heap of interaction tools for being able to very, very quickly build VR interaction. So we definitely want to leverage that because it's going to get us up and running very quickly, but we can't see it here yet because by default, you can't see anything except for verified packages. So we go to the advanced cog here and we open up the advanced project settings, and you can see this is actually just the package manager settings in project settings. And we click this little enable preview packages box. Okay, now we can see the XR Interaction Toolkit has shown up. It's actually very close to being released. It's a pre 1.0 preview release. And we're going to install that as well. Now we're going to be using the input system, Unity's new input system. And that can be a reasonably complex system to learn. It involves building some input actions that then get tied into specific behaviors. And if you don't know what you're doing there, it's very powerful, but if you're new to it, it can be quite complex. So we can actually take advantage of some default ones that are here under samples. So after we've installed this, we have our samples, and we will import the default input actions. Doesn't take long, tiny files. All right, and once that's done, if we look under samples, we'll have this new directory under assets, samples, the XR Interaction Toolkit, and we have these default input actions here. And all we need to do is select each one of these, have a look at the inspector for them, and we see at the top there's this button here called it says add to the something default, right? It's going to be different for each one. We're going to do that for each one of these, right? The action-based continuous, there's the controller. That's also the controller. We'll fix that in a second, and the snap turn. All right. So what we've done is we've imported these actions. These are the actual. This is the input actions file that I was talking about. So these are the different actions that have been already set up based around the different inputs, and we are then going to use these default presets. So with any import or any file that gets imported into Unity, Unity has a default way of importing it. If you've ever dropped an image into Unity, then you would have seen this before. You would have seen that there's a bunch of settings on the image that are the same each time. What you can actually do is change what those are by default and save them out as a preset, and then assign that preset to be how you want to import, say, all of your images for this project. You can do the same thing here. So the samples actually comes with a bunch of defaults, presets, sorry. And we're adding them to be the default preset, the default settings that we want to use. By doing this, when we create a rig later on through the menu, it's going to automatically wire all of this up for us. We won't have to do any of it. We don't want to do that manually. So this will sort of that out. The only thing that we need to check is that we have these two controllers that are almost identical, but they're tied to a different input source, right? So the left-hand controller is actually going to be reading the input from what is registered as the left XR controller. So we need to make sure that we can identify the two of those in our preset manager, and we can do that in this preset manager here. And the XR Interaction Toolkit is already designed with a filter for these. It's already looking for a filter. We just need to set the two presets with the same filter, right? So in this case, it's just right and left with a capital. So by putting this in, the code that has already been written in our XR interaction toolkit, it's looking for these two filters to know which one of the presets to use when you import it in. And I'll show you exactly what I mean by that. So when I go up to game object and I go to XR and I go to XR rig, right, this is going to build the whole rig for me, everything I need. You'll notice that they say action based. Action based is this new input system I'm talking about. We do still support the previous input system, Unity's legacy input system for now. This will get deprecated eventually, so it's a good idea to learn how to use the new one. But if you are more comfortable using the old one for now, you can. You just need to remember not to use any of the action-based options in here when you're creating new stuff. Make sure you're using any of these device-based ones. So when I create one of these, it's going to use all those presets that I just set up to pull out the input. Once we've added the XR rig, we notice a couple of things. We can see that our main camera, has moved from the root of the scene to being underneath this hierarchy here in the rig. And we can see that it has a track to pose driver using the new input system put on it. Here's the actions. Right, so this is what's going to track the head-mounted display and control the camera based on that. We've also got these two controllers, and the controllers you can see have all of our input actions already associated with it. And that's because we set up those presets. Right, we made them the defaults. If we hadn't have done that, then when we created this XR rig, these would be empty, and we would have had to drag and drop the appropriate ones off the list over on the left here, which would have been time consuming and error prone, right? So this solves it by using the presets. We also have an XR ray interactor. It's just basically a physics ray that can use the XR interaction toolkit to interact with things. We'll talk more about that in the next section. We have a line renderer so that we can see that ray. It's just a normal Unity line renderer. But then we have an XR interactor line visual, which is just a component that sort of overrides some of those line renderer settings to make it a bit easier to control and find where to set them. So we can control things like line length, line width, the width curve, so you might have it actually taper off to a thinner point further away, or vice versa, so it gets thicker the further away you are. And then we have these two colors that are actually gradients that you can control for when your ray is valid or invalid, which again has to do with whether or not you're pointing at something that can be interacted with. Now, we also got an XR interaction manager added to the scene that gets added automatically. There's no settings on it, it just does what it does. We also need to add an input action manager. So the new input system is designed to be able to swap out these input action assets. You can turn them off, turn them on. You can have different ones for different parts of your experience. You might have another one that's designed for running when you're in the menu, so that the same input does something different in those scenarios. And so they need to be turned on by code. And by default, they'll be off. So if we just hit play and we ran this now, we wouldn't be able to move our controllers. So this input action manager is just a little script that basically can take an input action, and at startup, we'll just enable it, turn it on so that it starts working, so that we don't need to write our own code to it. If we had some more complex behavior where we wanted to control when these things were on or off, and we had different input action assets, then we'd write our own code here. But because we just want this to be working from the start, we can just put it on this list and just have it working all the time, just turn it on. I think that's it for getting set up. There's a little bit more to do for UI later on, but we're not up to that yet, so we can just leave that here. And if we hit play, we should be able to get VR happening. That's the video you can hear. It's happening behind me there. Okay, we can see the reflections on the ground. You can see I can look around, and you can see my controllers. Right, so they're always red because I don't have any interactors set up yet. And then we've turned a a static VR visualization scene into a VR scene. So in the next section, we're going to start adding some navigation very quickly. Okay, let's take what we've done so far and add some navigation. So XR Interaction Toolkit comes with two different types of navigation built in. It's got a whole navigation system, or locomotion system as it's referred to in the classes. And you can extend that, you can build your own locomotion providers on top of that. But in most of the cases, you can get away with just the two that come with it. So the first one is what's called snap turning, and the second one is teleportation. So snap turning is very quick and easy to set up. Snap turning is simply the ability to use some input to rotate the user instantly by a certain number of degrees. This can be really, really useful if you've got limited space, if you're using a VR headset that has cables, or your user is likely to be seated, because that'll minimize the amount of physical turning around that they need to do to be able to look at things. They can use the snap turn to be able to jump their viewpoint around themselves without having to physically move around too much. They can still move around if they want to, or look over their shoulder, but they won't be constantly turning around and getting tangled in wires, or spinning on an office chair or something. So we'll set up snap turn first. To get started, we're going to need our locomotion system. So we're just going to add a new empty game object, just called locomotion, and we'll add the locomotion system to it. And all it needs is a reference to the rig that it's in charge of. So you could have multiple locomotion systems potentially controlling different rigs. And again, maybe you've got different parts of your experience that work differently. Maybe at one point the user can drive or something, and so you don't want them to be able to teleport, and so you switch out the rig or you switch out the locomotion system. There's probably a few different ways to do that. So that's the locomotion system. You can see it's got a timeout. The two locomotion providers that come with it, the teleportation and the snap turn, don't really use the timeout, but what you can do with the locomotion system, if you build your own provider, you extend out the code and build your own provider, you can lock out other locomotion systems while that one's running. And so you can then provide a timeout where if there hasn't been anything happening after a certain amount of time, it will release the locomotion system so that the other methods will work again. It's just a little fail-safe for if you get stuck somewhere. But you probably won't even use that because the two that come with it don't need it. You can snap turn and teleport at the same time. They don't actually request the locomotion system to lock all the rest out. Okay, we're going to add a snap turn provider. Remember, we're using the new input system, so we need the action-based one. It needs a reference to the locomotion system that it's a part of, and otherwise everything else is set up for us. The only thing that I'm going to change is turning off the right hand. So by default, you can use left and right hand. Usually when I build my experiences, I have one hand for being able to navigate and the other one for being able to interact. If I'm building a more fleshed out experience, I would spend the time to write some code to have some settings to be able to control that so that the user can say, well, I'm left-handed, so I want to be able to pick things up with my left hand and navigate with my right instead and swap those things around. But if I'm just building a fast prototype, then I usually do it this way because I'm right-handed. So I like to be able to pick things up with my right hand and navigate with my left. So this way, only my left hand controller can do this snap turn. You can see here that's the turn amount. So each increment is going to be 45 degrees. The debounce time is just to sort of limit the chance of accidentally doing another snap turn when you release the input. I'm letting you turn all the way around, and I'm letting both directions be okay. And then it's tied to this turn action, right, which is a part of our input action asset. And that's actually set up to be the thumbstick on the controller, right? So our left thumbstick is going to let us do the snap turn. And that's it. If I hit play now, I can do snap turn. Right, so if I pick up my right hand, I can't do anything. If I pick up the left, I can snap turn 45 degrees at a time. Yeah. Let's add teleportation. It's not much more difficult, but there's a few more components to it. There's still a provider that we need to add. So we can add that, add the teleportation provider, and it needs a reference to our system. These don't have to be on the same game object, they might be on different game objects. I just keep all mine together so I can find them again. Now, we need a teleportation area, right? And so what we're going to do is select the floor. So if we go, let's see, I think it's floor exterior. That's the object I'm looking for. You can see this orange outline here. So that floor exterior, it's actually already got a box collider on it. So I'm just going to, let's see, I'm going to add a teleportation area to this. We won't worry too much about the settings on here just yet, but you see that it needs a teleportation provider, right? So these tying these two things together so that they talk to each other. So we just drag that locomotion object in here, and that's the two things tied together. Let's see. So that should work. I should be able to teleport around. And you'll see that when I point at the floor, I actually get white now because it recognizes that that's an interaction that's valid. And I can pull the grip on my left hand, but you'll notice that I can't go onto the carpet, right? Because it's also got a collider on it that's blocking me. Right, I can use the snap turn. So let's actually, before I forget, let's go in and find that TV, then the video player, and we are going to turn off play and wait so it doesn't start up every time. We're going to have some interaction with that later on, but for now let's stop that playing every time. Okay, so I could add teleportation areas to like the carpet or around this corner because that's another section of floor that I couldn't go to before. Or I could have one teleportation area with a list of colliders. All right, so that's what I'm going to do. I'm going to go back into here. I'm going to find my floor exterior. I'm going to remove that, and I'm going to create a new empty, and we'll just call this teleportation area, and we will add a teleportation area to it. And you'll see that we have a list of colliders here. So I can go up and I can find my floor exterior and I can add that onto my list. But then I can also find this rug. And you'll see that it's got a series of LEDs on it. And the bottom one here is called underscore COL with the collider, and it's literally just a collider. It has no renderer capacity on it. It's just the collider for that object. So we will go to our teleportation area. I'm actually just going to lock that in so I can select things. Select my rug, drop that collider on. And then there's this section. What's this? Floor 2. Is that the one I wanted? Let's see, floor exterior. There's office floor exterior. So yeah, the office floor exterior, that's the one I want. So we'll drop that one on here too, and then the rug. And then we hit play, and I should be able to now traverse those other areas. Okay, so now I can go onto the rug. You can see I can't go onto the table because there's a collider on that. And same with the couch. But I can go over to here now. And I can teleport around here as well. Okay. Now, what if we want something other than a straight line for teleportation, which is pretty common because in this particular scenario, it's not too bad. We're inside a fairly flat room and there's nothing other than the floor we really want to be able to teleport to. But if you were building, especially something that was outdoors or something like a large indoor foyer space, or even just a large indoor space with multiple floors, maybe a theater or something, and you want to be able to get up to the higher levels with teleportation, that's going to be quite difficult to do with a straight line. So what we can do is change our left-hand controller, just untick that little look, and we'll have a look at our XR interactor, and you can see that our line type here is a straight line. And what we can actually do is change this to a projectile curve. And then when we hit play, it'll actually give us a nice little curved line instead of a straight line. All right, now, depending on the size of the space that you're looking at, you may want to play with some of the settings here around the velocity and the acceleration. So if I up the velocity, you can see that it changes the curve, and also the number of sequences, and potentially this line length here. You'll see that if I go too high, it's hard to tell inside because there's not enough space, but the line will actually stop when it reaches its limit. And so if you need a really big space, you may have to extend the line and play with some of these values to get a curve that's nice and allows you to sort of shoot up quite high and still land on a higher platform. So we talked briefly before about having the two different hands do two different things. That was fine for the snap turn. It was pretty easy to do. We just unchecked the right hand. But for the left hand, it's a little bit different because we're not defining a specific controller as the input. For teleportation, we're actually using the interaction toolkit system of interactor and interactable. And so this can get a little bit complicated, but this is our first foray into it, and it's sort of one of the core components of everything that we do in here. So we can see that we have an XR ray interactor on our hand, on the controller. That's a type of interactor, and there's a couple of other types that we have that we will talk about in a little bit. If we look at our teleportation area, we can't really see it here because it's called a teleportation area, but this is an interactable, and what that is something that can be interacted with via an interactor. And it does that using a layer mask. So let's make a new layer mask. So this is, if you've done anything with Unity before, you've probably seen layers before. Layers are used by the rendering system, they're used by the physics system to be able to separate objects out. And they're used by the interaction toolkit, but in a very different way. So we're going to add a layer. I usually try to start from the bottom because the ones at the top here are going to be your usual layers that you use for physics interactions and stuff like that. And they're going to be things that you put specific game objects onto. When it comes to the XR interaction toolkit, you don't use layers that way. You don't put game objects on the layers to be able to use them. Okay. So we're going to create a new layer, which we will call teleport. So that's how you spell teleport. Teleport. Okay, so we're going to have the teleport layer, but we don't need to put any objects, like actual game objects, on that layer. We just need to tell interactors and interactables if they can interact with things on that layer. So if we go to the left hand, we can see that it has an interaction layer mask. And it's a layer mask. And if you've done any sort of programming before and you've looked at masks or you understand what they are, that's great. But if you're new to that, then it might be a bit confusing. But essentially, you can look at a layer mask as being a collection of Boolean values, true or false values. They're actually bits that are either 0 or 1, but you can treat a 0 or 1 bit as true or false in the same way. So when we look at this interaction layer mask that says everything, it actually is a collection of ones, right? So if you look at each one of these layers, if we go to our layers, and we can see we've got 32 layers here, 0 to 31. That's actually 32 bits. And each one of these that we've given a name to, that's just a human readable name to that particular bit. Really what we're saying is bit 31 is a on or off. But that's hard to remember and confusing, so we name bit 31 teleport. And we're saying, is the teleport bit on or off in this mask? So if we go to our left hand, its layer mask has everything on, so it's just ones all the way across the board. If we go to the teleportation area, it's got an interaction layer mask that is also ones all across the board. So when you have an interactor and an interactable, all they do to figure out if it's a legal interaction, a valid interaction, is compare these two masks. If any of these are on in both of them, then it's a valid interaction. Right? So we want the teleportation area to only have teleport on. Okay, so if we now go to my right hand and I turn off teleport, now when my right hand XR ray interactor, when that ray hits the teleportation area, the whole interaction system, this interaction manager system, is going to look at these two masks and it's going to compare them. And it's going to say, are any of these on in both scenarios? In this case, everything except teleport is on. And in our teleportation area, everything except teleport is on. So there won't be any matches. So this will come back as an invalid interaction. So my right hand can no longer interact. If I change my left hand so that it only interacts with this, right? This means I can teleport with it, but it means I can't do anything else with it. So later on when I start to add more interactables and they've got different interaction layer masks, my left hand won't interact with them. If I want to interact with picking things up, I won't be able to do it. I hope that made sense. That's kind of the trickiest part to wrap your head around. It's piggybacking the layer system that we already have, but it's not using that in the traditional way that we use it inside of Unity, where you actually put game objects on one of these layers. The game object, let me say that again. The game object itself, the left-hand controller, it's on the default layer. Like it doesn't actually matter what layer this is on. And in fact, a game object can only be on one layer, but a layer mask can have multiple layers on it. So I hope that makes sense. In the next section, we're going to start looking at being able to grab things. Okay, now we're going to have a look at being able to grab things. So there are two things in this scene that are marked as not static, right? Meaning that we can move them and their shadows are dynamic. You might remember from the start of the webinar that we mentioned that we've got mixed lighting, so some of it's been baked. A lot of the things in this scene are static and baked in, and there's a couple that aren't. One of those is a coffee machine, and the other is a coffee table. I think it's that coffee table over there, and this coffee machine here. Let's not pick up the coffee table. Let's pick up the coffee machine. So let's have a look at it. Let's select it. Here we are here. Right, that's the shelves. There's the coffee machine prefab. Okay, so we can see that it doesn't have a collider yet, and we're going to need a collider to be able to interact. So let's add a box collider, and it probably is a bit big. So if we look at it from this perspective, let's change to our orthographic perspective, and we're going to turn on our little edit collider handles. I'm going to grab this handle and I'm going to bring it in. I might bring that down a little bit. And now let's have a look at the front. Yeah, that looks fine. And the top should be fine. Okay. So we've done that. And the second thing that we want to add to the copy machine is a rigid body. This means that it will react to physics, right? So when we pick it up, it'll fall when we let it go. We want this to be able to react with physics. If we don't put the rigid body on it, then when we pick it up, we move it around, then we let it go, it's just going to hang in midair wherever you want. So if that's what you want to do, if that makes sense for what you're trying to do, then that's fine. Just leave the rigid body off. But in most cases, you want that physics interaction in there. We'll change its collision to continuous. That just makes it a bit more accurate with its physics detection. So if it's moving very quickly, for some reason, it's still going to collide with the collider and not pass through it. There's obviously more computational overhead for that, but if you don't have a lot of things using physics, then that's fine to leave on, and you generally use that on the more important objects. And then the last thing we need is an XR grab interactable. So as you can see, this is interactable. So this is what we were talking about before. We have an interactable on the object, and we have an interactor here on our hand. Right. So those two things can communicate with each other. Where to go? There it is. Okay, so we want to be able to only interact with it with our left hand. The main way to do that would be to at least turn off the teleport layer so that we can't use our right hand with it, because we set up our right hand to only use the teleport layer mask remover. Or we could add another layer, right? So we might go in and we add a then we select, and we have this only work on our grab layer. We don't need to set the collider here because it's got one on it, and so by default it'll use the collider on this game object. And that should be all we need. So if we hit play, it won't be exactly what we want yet, but I'll show you what it does. Okay, so my left hand is my teleport. My right hand, you can see, doesn't interact with anything until I miss something. This. Let's have a look. We go to our right-hand controller. You can see that it doesn't have any of the new layers that we added on. So let's actually set it to nothing and just on the grab layer. All right, so that was a prime example. It had a whole bunch of masks or bits in the mask turned on, but not the one that the object had on. And so those two interactor and interactable things weren't valid. So now our right hand, anything that's on the grab. Okay, so if I pull the trigger here, I'm going to grab this and see what happens. Okay, you can see it flew to me and is now in my hand. So as I move my hand, and it's pivoting on the center of this object. All right, so I can now throw that over there. So by default, it's going to pick things up from a distance because this is the ray interactor. All right, so we can interact with things from a distance as far as this ray can shoot, which is probably not what we want for something that's realistic. There may be some scenarios where we do want to interact. It might not be a grab interaction, but we may want to be able to interact with things from a distance. And so it would still make sense to have a ray interactor. But, and things like UI. But for picking things up, we don't want to be able to do that. So what we're going to actually do here is duplicate this hand. So I select the hand controller and I press Control D. I want a second version of it, which I'm going to call right hand controller underscore grab. Now I'm just going to disable the other one for now, right, and then turn it off. Now this is going to be the controller that is used for picking things up. Okay, so I'm going to remove my ray interactor, and then I'm going to be able to remove the line renderer because I don't need to render any lines. And I'm going to add a XR direct interactor. Okay, it's a very simple interactor, and all we're going to do is change it so that the layer mask is set to that grab, and we just need to add a collider to it. So previously we had a ray interactor that produced a physics ray, and that's how it interacted with the collider on the coffee machine. Now we don't have a physics component that's going to interact with that collider that tells this thing when there's been an interaction or when to check if it's a valid interaction. So we need to have a collider on this. Now we don't want this collider to be a sort of a physical collider, right? If we leave it the way it is now and we put this sphere on our hand, we'll never be able to actually pick up the coffee machine because this sphere is going to push the coffee machine away from us. Right? The two colliders will interact and push each other away. So we need this to be a trigger. So a trigger collider can enter another collider. It still triggers the physics system, but it doesn't elicit a physical response in the other collider and force it to move. Now the radius is 0.5, so that's in meters, so that's probably a bit big. If we go to our hand, we probably don't want a 50 centimeter radius around ourselves to be able to pick things up. It probably makes more sense to be something like 5 centimeters. Right, so around our hand here, we're going to have basically a 5 centimeter radius or a 10 centimeter diameter sphere, which is probably not too far off the size of your fist. And I think that's probably all we need here for this to be able to work. But since we don't have a fancy colored line here that tells us when we are pointing at or interact with something that is a valid interaction, we need some other sort of feedback, right? And one thing that we can do is hook into these haptic events. So what we can do is add an on hover entered event. And so that'll get triggered or fired whenever we meet the hover condition. With an array interactor, that hover condition would be the same one that causes the line to go white. So whenever we're pointing at it, we haven't hit any buttons, we haven't interacted with it in any way other than our interactor has found an interactable that is valid. In this case, the hover event happens when our two colliders intersect. So the collider, the sphere collider in our hand, when it intersects with the collider on the coffee machine in this scenario, then our hovered state is entered. And so that's what we're going to do to trigger this haptic feedback. And haptic is like a physical vibration. We don't want it to be very big, otherwise it's going to be quite annoying and obnoxious, especially if there's a lot of interactions. So not very big and not very long. So now when we pass our hand through it, we'll get this little buzz in our controller. Now the last thing we might do before I show you this working is just have another look at our copy machine. Oh. And we saw that when we picked it up, it was like at the very base of the object, and it was a little bit of a awkward place to hold it. So what we're going to do is add an empty object underneath the copy machine, which we'll call attach point, and we will set this to be probably where it was, but about I think I wrote this down, 0.14 on the Z, and just slightly out there. And we will rotate it so it's facing the other way. That way it's facing towards us instead of away from us. And when we go into our XR grab interactable, you can see that there's this attach transform. So by default, if you leave it as nothing, it'll use this object's transform, but you can assign one. So I'm going to say this object is where I want to attach to when I pick it up. All right, let's see how all that went. So now my left hand, let's have a look here. My left hand still has my teleportation. All right, my right hand, which you can't see, but I'm holding it right in front of my face, doesn't have any line on it now. So when I get close enough to this thing, if I reach out, I can feel a little buzz in my right hand. And when I hold the trigger, I now have it holding towards me based off that attach point. So now I can have a bit more control over where I put it. Okay, and that's grabbing. So in the next section, we're going to have a look at adding UI to our environment and how we interact with the UI. Okay, now we're going to have a look at adding UI into our scene and how to interact with it. So building UI in VR is basically the same as any Unity application. There's just a few things that we need to set up a little bit differently. There's some of the interactors stuff needs to be set up, and there's a few differences because we're going to be working with world space canvases instead of the usual screen space ones you're probably using when you're building other applications. So the first thing we're going to do is add our canvas. Right, so the canvas is the root object that all of our UI components live inside of. If you've done any UI with Unity before, then you'll be familiar with canvases. We could go into Game Object, UI, and Canvas, or right-click, UI, Canvas. But that's going to create a canvas with all the default settings that we normally have in a normal application. What we could do is actually use the one that's inside of this XR menu that has come with our XR plugins and choose the UI canvas that's in here. And what that'll do is actually make it world space for us. Right, so it's created a world space canvas with the camera already set up on it. It's got a tracked device graphic raycaster, which is one of the components we need to remember. Normally we just have a graphics raycaster, but we need to be able to have this tracked device raycaster so that our controllers work properly on the UI. And then it creates an event system, same as our normal canvas would have, except that this event system has the XR UI input module on it instead of the usual UI input module, the default one. Right, so these things we would have to remember to do ourselves if we did it the other way. We'd have to go in and change it, remember to add these components, otherwise we wouldn't be able to interact. So I 100% recommend that you just use the XR menu when you create your canvas. Right, use the UI canvas in this menu and it's going to set everything up for you. All right, so our canvas is still going to be the default size, right, which is 100 by 100. Now, normally when you're talking screen space overlays, 100 by 100 is basically pixels. When we're talking world space canvas, that's meters, right? So our canvas here is 100 by 100 meters. Right, way too big for what we want to do here. We want to build some UI inside of our scene. So we're going to change that. So the width is about 1.5 meters by 0.3 meters. And we want to move it so that it's somewhere underneath the television. So let's bring it over here, go to the wall. put it roughly just somewhere over the top. Okay, we're going to add a button. And this is all just the same way as normal. You don't need to keep going into the XR menu to find some special VR button. From this point on, it's just normal UI. The tracked device graphic raycaster and the XR UI event component, they handle interpreting all of our XR interaction stuff and feeding it into the normal UI system. So we can just add a button on here. Yeah, let's import TextMesh Pro. Okay, now our button obviously is too big, so we can just sort of scale it to fit. Right, so it fills our canvas. You'll notice that it doesn't look great, it's pretty blurred out, and that's because if we look at our canvas and we look at our reference pixels per unit, it's at 100, but if we look at our button, pixels per unit multiplier is 1, so if we make it 100, that'll match up a bit better and look much smoother. On the text, at the moment we can't see the text because by default it also is too big. Remember, this is all the defaults are set for basically pixel dimension, not world space dimension. So we set this to auto size, set the maximum to maybe 10, and we can see that our canvas is facing the wrong way. So let's rotate it around that way. Okay. Let's see, let's change the text to toggle video, something like that. And let's actually, because that's pretty gross, let's bring the, oops, wrong one. Let's make it, okay. Very much control button. That looks a bit better. Okay, we're going to do a little bit of visual scripting. Now, if you're using Unity 2021, then visual scripting is already built in for you. But prior to that, you still need to import it using the asset store. So I should already have it in my package manager. I go to my assets. We'll go to Bolt. Here we are. So I can download that. And then import Bolt. Okay, we get our nice little wizard to set up. I recommend choosing human naming. I'm not going to go too deep into how to use Bolt. We have some other webinars on how to use Bolt. So I'm just going to walk through the steps here. We can leave this here. We could add our XR interaction toolkit namespace. That'll give us access to any of the XR interaction toolkit methods that we might want. We can leave all that and hit generate, and that's going to generate nodes for all of our code. And then we're going to build a fairly simple little node graph to being able to control what this button does when we click on it. So we're going to create a flow machine. Again, if you're using the visual scripting in Unity 2021, that's called a script machine instead of a flow machine. And we're going to put that on our button. So we'll close that, select our button. We're going to have a flow machine. Okay, and we're going to change this to an embedded one. Again, I'm not going to go into details about what all this is, but we'll just call this toggle video. Okay, and then we just hit edit graph. and we're going to get rid of these. So you can see that it starts with a start and an update event, very similar to when you create a new model behavior. We don't need those. We're going to add a variable in the inspector here called video player, and it's actually a video player component. And now that that variable exists, we need to actually give it a value. So this is the video player in the scene, right? If we select this, it's the one that's sitting on the TV. Yeah, the one that we turned off the player a week before. Right, so all we did here was create a new variable of that type, give it that reference, so that we can access it inside of our graph. And we're just going to say get video player node. So this is just a get variable node that's looking for the name of this variable called video player. Then we're going to have an on button click event. Okay, and this will automatically tie itself in because you can see it references itself, and we actually have a button on this object. So this is going to tie into the on button click event on this specific button. And then we are going to pull this out to a branch node. Now, if you're in Unity 2021 and using the sort of embedded visual scripting, branch has been renamed to if, so you won't find branch, you need to search for if. And we want this to be video player is playing. So what we're doing is we are saying this if statement needs a true or false condition to check. The condition we're giving it is the is playing value. And let me just go to full screen here so it says. So this node, you can see this node outputs a Boolean, and you can tell that's color coded as well. So Boolean values are pink. So this is playing is a read-only true or false value that belongs to the video player component, which we have a reference to from this variable that we stored. So we're saying that if is playing is true, then we're going to do this logic up here, and if is playing is false, we're going to do this logic down here. So this is fairly straightforward. The true is just going to call video player dot pause. And we'll give it that reference there as well. It's the same video player. And this one is going to be video player dot play. Again, that same one. Double check this because I always get confused here. So if we are playing, we want to pause. If is playing is false, then we're going to play. Okay, so we can come back out of the screen. Pretty simple graph, nothing too crazy. Make it a bit, try and make it a bit easier to read. I don't know, that's easier enough, but. Okay. So now we need to re-enable our original left-hand controller under our rig. Right-hand control, sorry. So we'll re-enable this object. And we're going to set the interaction layer mask to nothing, because the UI system is just Unity's normal UI system, right? So it's not using the interactor part of things. It uses this XR UI input module here to basically just translate UI or translate XR inputs as UI events, right? So it works outside of that system. So our right-hand controller with the ray doesn't interact with any of our interactables, but it still will work for the UI. And on the other hand, on our on our right hand, on our left hand, we are going to disable this little flag here that says enable interactions with UI objects. So now our left hand with its curved teleportation ray isn't going to interact with UI objects. So now if we hit play, right, we can look around. I can teleport, and you can see that my hand here goes white. The ray goes white when I point at the video, and if I pull the trigger, I can pause it, play, pause. All right, and that's our basic system. You can build any of your normal UI interactions the same way you normally would, and you'll be able to interact with it using your VR interaction. So, okay, and just lastly, we're just going to talk very quickly about Weaver. It's bizarre. So Weaver is, as I mentioned, a verified solution partner for Unity. It's a VR training solution that's built on top of Unity. Consists of 3 parts, 3 systems. It's designed to build VR training scenarios without any code. It has a management portal. It's designed to be open enough to integrate with existing systems like any LMS that you're already using or that you want to use that's on the market already. And if you're looking to explore virtual reality training for your company and you've got a little Unity experience in-house, then I would definitely talk to some of our friendly business development managers about Weaver. If you don't have contact details for BDs, then pop a message in the chat and one of us can reach out to you directly and sort out who's in your area that you can reach out to. But I'm going to play this video. It's going to walk through the whole thing for you. And if you've got questions about Weaver specifically, I would reach out to us via email. So as you can see, Weaver's a very feature-rich tool that gets you up and running to build this stuff very, very quickly. You could build it with Unity yourself. Obviously, this has been built on top of Unity as well. But you would take a lot of time and resources just to get that up to the level that Weaver's already at to start off. So I definitely think if you're thinking of building VR training or you're looking to validate it, Weaver is worth checking out and building something with and getting some metrics on. So I'm happy to take any questions now if anyone has any. Otherwise, thank you very much for your time.
Oh, we did not have many questions throughout that, so that's probably the least number of questions I think I've ever